This is Shiva Reddy, chemistry faculty. Now we are going to discuss about fundamentals in organic chemistry. So what is meant by organic chemistry? So the branch of chemistry that deals with the study about hydrocarbons and derivatives is called as organic chemistry. So carbon forms a million number of compounds. Carbon forms a million number of compounds. Carbon forms a million number of compounds. So because of number one, tetravalency. Number two, formation of multiple bonding. Formation of multiple bonding. Formation of multiple bonding with identical carbon atoms. Identical carbon atoms. And also with oxygen and nitrogen atoms. Oxygen and nitrogen atoms. Third one, catenation. And fourth one, isomerism. Isomerism. So carbon forms a million number of compounds because of tetravalency, formation of multiple bonding with identical carbon atoms as well as with nitrogen and oxygen. And catenation, and fourth one is isomerism. So now we are going to discuss about what is meant by tetravalency, how the carbon forms tetravalency, how the carbon possesses tetravalency. How the carbon possesses tetravalency. The atomic number of carbon is 6, whose configuration is 1s2, 2s2, 2p2. 2s2 means it is completely paired. 2px1, 2py1, 2pz1. This is the ground state configuration of carbon. So we observe the ground state configuration. It has the two unpaired electrons. So in ground state, carbon has a tendency to form. Only two bonds. But in its compounds, carbon possesses a tetravalency because carbon has a vacant orbital in its outermost orbit as well as a paired electron. So undergo excitation, the 2s electron undergo excitation to 2p. Its excited state configuration is 2s1, 2p3. 2s1 means unpaired, 2px1, 2py1, 2pz1. It has 4 unpaired electrons. 4 unpaired electrons and possess tetravalency. So next. So what type of hybridization shown by the carbon atom in its organic compounds? So how they form multiple bonds with identical atoms as well as maybe oxygen or maybe nitrogen. So in organic compounds, carbon shows sp3 hybridization, sp2 hybridization and sp hybridization. What is meant by sp3? 1s orbital plus 3p orbitals undergo intermixing and forms 4 sp3 hybrid orbitals. So we observe the excited state configuration of carbon. It is helium 2so1, 2p3. This is the first excited state configuration. So in first excited state configuration, The carbon atom is in sp3 hybridization. Sp3 means 1 s orbital and 3 p orbitals and forms 4 sp3 orbitals. That means the carbon atom is surrounded by 4 single bonds or maybe 4 sigma bonds. The carbon atom is said to be sp3 carbon atom. One of the carbon atom is surrounded by 4 sigma bonds or maybe 4 single bonds. The carbon atom is said to be sp3 carbon atom. Similarly, sp2 hybridization means 1 s orbital plus 2 p orbitals. 1 s orbital plus 2 p orbitals. Ma forms 3 sp2 hybrid orbitals. So, in sp3 hybridization, there is no pure orbital. In sp2 hybridization, 3 are hybrid orbitals, and one is a pure orbital. That means the carbon which one is surrounded by 4 single bonds or 4 sigma bonds, the carbon atom is said to be sp3. One carbon atom is surrounded by sigma. In pi bond, 1 sigma and 1 pi. In double bond, 1 sigma and 1 pi. We observe that the carbon atom is surrounded by 3 sigma and 1 pi. Then the carbon atom is said to be sp2 hybridized carbon atom. So the carbon atom is surrounded by sigma, pi. 2 sigma and 2 pi. The carbon is called as sp. Once we have to observe that the carbon which one is surrounded by 4 sigma bonds, the carbon atom is called as sp3 carbon atom. The carbon atom which one is surrounded by 3 sigma and 1 pi is called as sp2 carbon atom. The carbon atom which one is surrounded by 2 sigma and 2 pi is called as sp. And how can we find out the ratio of pure and hybrid orbitals? And how can we explain the properties of carbon based on the hybridization? Point number 1. In hybrid orbitals, as the percentage of S character increases, what happens? For example, sp3, sp2, sp. sp3 means 25% S character, 75% P character. sp2, 33.33% S character, 66.67% P character. sp means 50% S character and 50% P character. So, in hybrid orbitals, as the percentage of S character increases, sp3 means carbon-carbon single bond. sp2 means there is a carbon-carbon double bond. sp means there is a carbon-carbon triple bond. Carbon-carbon single bond. This is a saturated carbon, alkane. C double bond C, C triple bond C. These are unsaturated carbon atoms. Either maybe double bond or maybe triple bond. Carbon-carbon single bond length 1. 54 angstroms. Carbon-carbon double bond length 1.34 angstroms. Carbon-carbon triple bond length 1.20 angstroms. Bond angle. This is 109 degrees 28 minutes. sp3 hybridized carbon. 120 sp2 and 180 sp. That means as the percentage of S character increases, bond order, as the percentage of s character increases, bond order increases. In alkane there is a single bond between carbon atoms, alkene double bond and alkane triple bond. So as the percentage of s character increases, first one, size of hybrid orbital decreases. Size of hybrid orbital decreases. As percentage of s character increases, size of hybrid orbital decreases. Order of size of hybrid orbitals. Sp is less than sp2 is less than sp3. So as percentage of s character increases, size of hybrid orbitals decreases. Second one, bond length decreases. As percentage of s character increases, bond length decreases. We have to observe that. In C double bond C, the percentage of s character is 25. The bond length is 1.54 angstroms. C double bond C, the percentage of s character is 33.3%. The percentage of s character is 1.34. C triple bond C, the percentage of s character is 50 and the bond length is 1.20 angstroms. 1.20 angstroms. So, as percentage of s character increases, bond length increases. Bond length decreases. Bond length decreases. Third one, bond angle increases. Bond angle increases. The bond angle of sp3 carbon 110 degrees 28 minutes, sp2 120, sp 180. As percentage of s character increases, bond angle increases, bond length decreases, and bond energies increases. Bond energy increases. Bond energy increases. Generally, bond length inversely proportional to bond energy. Bond length inversely proportional to bond energy. Next one, as percentage of s character increases, electronegativity of carbon atom increases. As percentage of s character increases, electronegativity of carbon atom increases. sp3 carbon is less electronegative than sp2 carbon atom. sp2 carbon atom is less electronegative than sp carbon atom. So, as the percentage of s character increases, the number of bonds between the two identical carbon atoms increases. That is, bond order increases. As bond order increases, bond length decreases. As bond length decreases, bond energy increases. And as percentage of s character increases, size of hybrid orbital decreases. Bond length decreases, bond angle increases, bond energy increases. The electronegativity of carbon atom increases. sp3 carbon atom is less electronegative when compared with the sp2 carbon atom and when compared with the sp carbon hybrid orbitals. First one, calculation of hybrid orbitals. Calculation of hybrid orbitals. Next, calculation of pure orbitals. Total number of hybrid orbitals equal to 4 into number of sp3 carbon atoms plus 4 into number of sp3 carbon atoms plus 3 into number of sp2 carbon atoms plus 2 into number of sp carbon atoms. Total number of hybrid orbitals is equal to 4 into number of sp3 carbon atoms plus 3 into number of sp2 carbon atoms plus 2 into number of sp carbon atoms. Total number of pure orbitals equal to 1 into number of sp2 carbon atoms plus 2 into number of sp carbon atoms plus total number of hydrogen atoms present in a compound. For example, CH3 single bond CCH3 double bond CH single bond C triple bond CCH3. Question number 1. Find out hybridization of carbon atoms in a given compound. Second one, find out the ratio of pure and hybrid orbitals. These are the questions. Question number 1, find out hybridization of carbon atoms in a given compound. Question number 2, find out the ratio of pure and hybrid orbitals in a given compound. The given compound is CH3C CH3 double bond CH C triple bond C CH3. And once we have to check it, the carbon which one is surrounded by 4 sigma bonds, that is sp3 carbon atom, 3 sigma and 1 pi sp2 carbon atom, 2 sigma and 2 pi sp carbon atom. Now CH3 means H bond C bond H H single bond, C bond H wait, H bond C bond H single bond, C bond C H double bond C bond H single bond C triple bond C CH3. This is the given compound. A single bond is sigma. The carbon is surrounded by 4 sigma bonds. Hence, this is sp3 carbon atom. Sigma pi sigma. This is sp2 carbon atom. This is 4 sigma bonds. Then this is sp3 carbon atom. Sigma pi. This is sp2 carbon atom. Sigma pi sp carbon. Here this is sp carbon and this is sp3 carbon. Then find out number of sp3 carbon atoms. Number of sp3 carbon atoms is equal to 1, 2 and 3. There are 3 sp3 carbon atoms. Number of sp2 carbon atoms. 1 and 2. There are 2 sp2 carbon atoms. Number of sp carbon atoms. There are 1 and 2. We have 2 sp carbon atoms. So the compound has 3 sp3 carbon atoms, 2 sp2 carbon atoms and 2 sp carbon atoms. So this is the answer for question number 1. To find out the hybridization of carbon atoms in compound is sp3 comma sp2 comma sp. The question number 2, find out the ratio of pure and hybrid orbitals. Then we are going to discuss about ratio of pure and hybrid orbitals. The total number of hybrid orbitals equal to 4 into number of sp3 carbon atoms plus 3 into number of sp2 carbon atoms plus 2 into number of sp carbon atoms. So HO is nothing but hybrid orbitals. 4 into number of sp3. So total number 4 into 3 plus 3 into 2 plus 2 into 2. So 4 3s are 12 plus 6 plus 4 total number of hybrid orbitals are equal to 22. So next, PO means pure orbitals. 1 into number of sp2 carbon atoms, 1 into 2 plus, 2 into number of sp carbon atoms, total number of hydrogen atoms, in the compound, CH3 single bond, CCH3 double bond, CH, C triple bond, C, CH3. Here 3 plus 3 9 plus 1 10 and 13. So 2 plus 4 plus 13. The total number of hybrid orbitals, pure orbitals are 19. The ratio of hybrid orbitals, the ratio of pure orbitals and hybrid orbitals equal to 22:19. This is the calculation of the ratio of pure orbitals and hybrid orbitals. So next, we have to take another example. The next example is benzene. The next example is benzene. Its formula C6H6. It is a monocyclic compound. So this is carbon, and each carbon has one hydrogen atom. So the number of hybrid orbitals and pure orbitals in benzene is, this is carbon, sigma, sigma, sigma 5. That means in benzene each carbon atom is in sp2 hybridization. We have 6 sp2 carbon atoms. So 3 into 6, that equal to 18. Pure orbitals, 1 into 6 plus number of hydrogen atoms 6. It is 12. So the ratio of hybrid orbitals is to pure orbital is equal to 18:12. 6 2 ja, 6 3 ja. The ratio of hybrid orbital and pure orbital is 3:2 in benzene. Then, which of the following compound has identical hybridized carbon atoms? Which of the following compound has? Which of the following compound has identical hybridized carbon atoms? Option 1, CH3CO CH3. Option 2, CH3 taken thrice COH. And option 3, CH3 CHO. And option 4, CH2 double bond CH, single bond, CH double bond CH, CH3. This is the given compound. So which of the following compound has identical hybridized carbon atoms? For example, CH3CO. Option 1, CH3CO. H bond, C bond, H bond, H, C double bond O, C, H, H, H. We observe the first one, the carbon, sigma, 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 sigma. It is sp3 carbon atom. Sigma, sigma, pi. This is sp2 carbon atom, here this is sp3. That means the compound option 1 has 2 types of hybridization. One is sp3, second one is sp2. Second option, CH3 taken thrice COH means O, H, CH3. It may be written as C, H, 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 C, H, 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 C, H, H, H. We observed that in a given compound, all the carbon atoms are in a same type of hybridization, that is sp3. Sigma, 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 sigma. This is sp3. This is sp3. This is sp3. This is sp3. So the option 2 is correct, because in all these carbon atoms are in a same hybridization, that is the sp3. Whereas option 3, H bond, C bond, H bond, H, and C double bond OH. This is acetaldehyde. The first carbon is sp3, but second one is sp2. Similarly, this is sp2, this is sp2, this is sp2, and this is sp2, but the last one is sp3. So we observe the second one, it has all the carbon atoms are in a same hybridization. So option 2 is the correct for the given question. So next, how can we find out the ratio of pure and hybrid orbitals? Similarly, how can we find out the ratio of sigma and pi bonds? Sigma and pi bonds. First, we are going to calculate sigma bonds. Number 1, open chain compound. Open chain compound. Number of sigma bonds equal to atomicity minus 1. In open chain compound, the number of sigma bonds equal to atomicity minus 1. Atomicity is nothing but total number of atoms in a molecule. Total number of atoms in a molecule. Second one, monocyclic compound. Monocyclic compound. Number of sigma bonds equal to atomicity. Atomicity means total number of atoms in a molecule. Third one, polycyclic compound. Polycyclic compound. Number of sigma bonds equal to atomicity plus n minus 1. Here n equal to number of rings. So how can we calculate number of sigma bonds in a compound? In open chain compound, number of sigma bonds equal to atomicity minus 1. In monocyclic compound, number of sigma bonds equal to atomicity. In polycyclic compound, number of sigma bonds equal to atomicity plus n minus 1. Here n equal to number of rings. Similarly, how can we find out number of pi bonds in a given compound? Number of pi bonds. First one, open chain compound. Containing carbon and hydrogen only, CxHy, x plus 1 minus y by 2. Open chain compound containing carbon and hydrogen. The given compound has only carbon and hydrogen. So the total number of pi bonds equal to x plus 1 minus y by 2. Second one, open chain compound containing carbon, hydrogen and oxygen. Oxygen only, CxHyO. Open chain compound containing carbon, hydrogen and oxygen only. The same formula, x plus 1 minus y by 2. Third one, open chain compound containing carbon, hydrogen and halogen. Open chain compound containing carbon, hydrogen and halogen, CxHy x small z. X plus 1 minus y plus z by 2. Fourth one, Open chain compound containing carbon, hydrogen and nitrogen. CXHY N capital Z. X plus 1 minus Y minus Z by 2. This is the calculation of number of pi bonds for open chain compounds. Similarly, monocyclic compound, number of pi bonds equal to x minus y by 2. Here what is x? X equal to number of carbon atoms in a given compound. Y equal to number of hydrogen atoms in a given compound. X small z is equal to number of halogen atoms. Number of halogen atoms. N capital Z equal to number of nitrogen atoms. Here what is X? X equal to number of carbon atoms, Y equal to number of hydrogen atoms, XZ equal to number of halogen atoms, and NZ equal to number of nitrogen atoms. Then we have to take one example for above explanation, that is calculate the ratio of sigma and pi bonds in benzene. So benzene is a monocyclic compound. Its formula C6H6. So benzene is a monocyclic compound. Its a formula C6H6. So benzene is a monocyclic. For monocyclic compound, number of sigma bonds equal to atomicity. Atomicity means total number of atoms in a molecule. So we observe the C6H6. It has 6 carbon atoms and 6 hydrogen atoms. So number of sigma bonds equal to 12 because it has 6 carbon atoms and 6 hydrogen atoms. Number of pi bonds, it is a monocyclic compound. Number of pi bonds equal to x minus y by 2. Here x equal to number of carbon atoms 6 and hydrogen atoms are 6 by 2. 2 1 ja, 2 3 ja. 6 minus 3 means 3. Then we have to go, we are observed as per the diagrammatic representation, it has how many sigma and how many pi bonds. Sigma. Similarly, this is sigma, this is a pi, sigma, this is a pi bond, sigma and pi. Find out total number of sigma bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the total number of sigma bonds are 12. We already calculated that is number of sigma bonds equal to atomicity 12. The number of pi bonds equal to pi bond, 3 pi bonds. So sigma bonds equal to 12 and pi bonds equal to 3. The ratio is 3 1 and 3 4. The ratio of sigma and pi bonds equal to 4:1. So this is the calculation of number of sigma and pi bonds. The other question is calculate the ratio of sigma and pi bonds. Calculate the ratio of sigma and pi bonds in 1,3 butadiene. The given compound is 1,3 butadiene. Buta means it indicates the root word. The root word means number of carbon atoms in parent carbon chain. But indicates 4 carbon atoms. C bond, C bond, C bond, C. Di means 2. In means there is 2 double bonds. The position of double bond is first and third. So this is a double bond. There is a single bond, double bond. Then here this is hydrogen atom and hydrogen. Because the carbon valence is 4. It is a tetravalent carbon atom. We have to satisfy tetravalency by hydrogen atoms. And this is hydrogen, and this is hydrogen, and this is hydrogen, and this is hydrogen. Next one, number of sigma bonds. It is open chain compound. Number of sigma bonds equal to atomicity minus 1. Atomicity minus 1. Atomicity means total number of atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The atomicity equal to 10. 10 minus 1, it has 9 sigma bonds. And number of pi bonds. The compound has only carbon and hydrogen. Number of pi bonds equal to x plus 1 minus y by 2. X plus 1 minus y by 2. Here x equal to number of carbon atoms. Number of carbon atoms are 4 plus 1 minus number of hydrogen atoms 1, 2, 3, 4, 5 and 6. 6 by 2. 2 1 ja, 2 3 ja. So 5 plus 1. So 4 plus 1 means 5. 5 minus 3, that means 2. It has 2 sigma bonds and 2 pi bonds and 9 sigma bonds. So the compound has 9 sigma bonds and 2 pi bonds. The ratio is 9:2. This is the calculation of sigma and pi bonds in given compound.